Today we will talk about levels of measurement. So, let's start at the beginning. Whenever we collect data, we're working with variables. A variable can be something simple, like age, or something experimental, like the condition a participant is assigned to. But not all variables are created equal. They can exist on different measurement levels, and there are 4 main ones we distinguish: nominal, ordinal, interval, and ratio. These build on each other from the lowest to the highest. Broadly speaking, they fall into 2 big groups: categorical variables and continuous variables. Let's first look at the nominal level. Imagine we're recording gender. Traditionally, this might mean male or female. These categories can't be ordered, and you can't perform calculations with them. Gender in this sense is a dichotomous variable. Dichotomous meaning it has only 2 possible values. Another example would be hair color. Hair can be black, brown, blonde, red, grey, or white, but we don't rank blonde as higher than brown. These categories are purely labels, and that's why we call this the nominal level. Now, stepping up one level, we get ordinal data. Think about education levels. Someone who only completed primary school has a lower level of education than someone who also finished high school, and someone with a university degree is at a higher level still. These categories can be ordered, but here's the catch. We don't know the exact distance between them. A university degree isn't twice as much education as a high school diploma. We can only say that one is higher or lower than the other. That makes this the ordinal level. Nominal and ordinal variables together form what we call categorical or discrete variables, because their values always fall into categories. On the other side of the spectrum, we have continuous variables. These are measurable on an uninterrupted scale and can, in theory, take on infinitely many values. Think about age, height, or even a score on a psychological scale. Continuous variables can be divided into 2 levels, interval and ratio. The difference between them comes down to whether or not there's a true 0 point. Ratio variables have an absolute 0. Take height, for instance. 0 height means the absence of height, and if someone is 2 meters tall, they are indeed twice as tall as someone who measures 1 meter. That's ratio data. Interval data, on the other hand, doesn't have a true 0. Take the temperature in Celsius. 0 degrees doesn't mean there's no temperature, and you can't say that 20 degrees is twice as hot as 10 degrees. But what you can say is that the intervals between measurements are always the same. The jump from 10 to 20 degrees is equal to the jump from 20 to 30. Now here's the practical part. In psychology, the distinction between interval and ratio isn't all that important. For categorical variables, though, the difference between nominal and ordinal is much more relevant. But there's another important layer to this discussion. Researchers themselves choose how to measure a variable, and that choice comes with consequences. Let's unpack why it matters. First, if you measure something at a lower level, like categorically instead of continuously, you usually need more participants. Demonstrating a relationship between 2 continuous variables requires fewer people than showing a relationship between categorical variables. Measuring continuously is simply more economical. Second, many variables that we think of as categorical actually turn out to be continuous once we look more closely. People often place things into categories, but those categories don't always reflect the underlying reality. By forcing categories, you may lose validity. Third, there's flexibility. You can always take a continuous variable and break it down into categories later. But the reverse isn't possible. If someone just ticks the box 35 to 50 years old, you'll never know if they were 36 or 47. Continuous measurement keeps your data richer. And fourth, categories can distort reality. Human groups are rarely cleanly separated into distinct subgroups. By forcing cutoffs, like drawing a line at age 35, you're saying that someone who is 36 is much more similar to someone who is 49 than to someone who is 49 who is 34. But in reality, that's often not true. Those arbitrary cut-offs can be hard to justify. So, the takeaway? Whenever possible, Measuring variables continuously is more powerful, more flexible, and often more accurate. Categories can be useful, but they come with trade-offs.